Welcome to solverfy.
So we can draw the free body diagram of this plumb bob, and we have force tension at an angle here of theta. Going straight down is, of course, mg, the force of gravity, and going to the right would be the force attached. So we can say that the force attached equals g mass mm divided by em squared. And so at this point, we can say that in order to find gravity, this would be equal to the gravitational constant times the mass of the Earth divided by the radius of the Earth squared. So here we can say that the sum of forces in the y direction equals 0. And we can say that force tension cosine of theta minus mg equals 0, which means that force tension essentially equals mg over cosine of theta. So when we have this, we can say that sum of forces in the x direction equals the force attached minus force tension sine of theta. So we can say, and this equals 0. So we can say that force attached is going to be equal to force tension sine of theta, which would simply be equal to mg tangent of theta. At this point, we can say that the force of gravity on the mountain would divided by d sub m squared would equal mg tangent of theta. M's cancel out, and so we have that theta is equal to arctan of g mass of the mountain divided by g dm squared, and this will equal arctan of the mass of the mountain radius of the Earth squared divided by the mass of the Earth times the d sub m squared. And this would be our answer for theta for part A. Now, part B is asking us to find the mass of the mountain. So here, if we model Everest as a cone, we can say that the mass of the mountain is simply going to be equal to the density of the mountain times the volume, and this would be pi r squared h over 3 times rho, the density. And so we can find the mass of the mountain. This will simply be equal to pi times 2,000 meters squared times 4,000 meters times the density. So 3 times 10 to the third kilograms per cubic meter. And then this will be divided by 3. So the mass of the mountain is going to be 5 times 10 to the 13th kilograms. At this point, we can say that for part C, D is going to equal 5,000 meters. So if D equals 5,000 meters, now what is the actual theta? So theta we know is arctan of mass of the mountain, radius of the Earth squared divided by mass of the Earth times d sub m squared. And we find that theta will equal arctan of 5 times 10 to the 13th kilograms times the radius of the Earth, 6.38 times 10 to the 6th meters squared. And then this will be divided by the mass of the Earth, so 5.97 times 10 to the 24th kilograms, and then times 5,000 meters squared. And theta is equaling 8 times 10 to the negative 4th degrees. So that would be our answer for part C. That is the end of the solution. Thank you for watching.